All right, thank you all so much for coming. And and as I go through, feel free to ask questions. I've got a lot of content here, but we'll get through it. So just real quick, a little bit about me. I'm the CTO at Crunchy Data. I'm also a committer, major contributor. I worked on this row-level security thing, so I have some idea how it works, although people keep changing it, so I don't know. I also worked on column-level privileges, the role system, and I contributed to PGCL and PostgreSQL. All right, enough about me. So what is row-level security, right? The idea behind row-level security is to have an individual view of the data in the system, be those tables, rows, typically what we're talking about, and that way you can have kind of a subset of a table be visible to you. But one big point here is that we still maintain all of the relational consistency and normalization within those tables, right? So the way that it works is that it filters all the records returned from all queries, and you can also limit what records are able to be added to a table. You can do that based on user. Part of the way RLS works is that policies have to always be applied once row-level security is enabled for an object. And if there are no policies, then we have kind of a default deny approach, right? And I'll harp on that a little bit more as we go through. Policies are also able to be either restrictive or permissive policies. That was actually added a bit later on from the original RLS, and I will talk about that a bit more later. So when you want to go set up RLS, there's really just a couple of main things you have to do. You do have to enable row-level security on the table itself, and then you have to create whatever policies you want to be used with that table. There are two different types of expressions that you use when you're talking about policies. The first is a using expression. Okay, the using expression says what rows in this table are visible to whatever the executing command is. And we'll talk a bit more about that later. With check expression says what rows, or what data in the row is allowed to exist in either new or the result of an update statement. Okay, so using clause with check clause. So the way that RLS works is that with the using policies, the using clauses, those are added to each query as a conditional, right? They basically go into the where clause. This happens during the query rewrite phase, so pretty early on. So the way that things work in Postgres is we do parsing first, then we do query rewrite, then we do optimization, and then we do execution. So if you have something like a select star from my table and you have a policy, that becomes select star from my table where policy, okay? The same goes for update and delete statements. The things in the where clause that can exist are pretty much anything that you could put into a where clause. This includes references to other tables. So if you wanted to put a sub-select into your policy, that is something that you can do, and it can go off and reference some other table. You can even have it call functions that reach out into operating system space, like maybe ask something of SE Linux, for example. And as mentioned, all of the optimization happens after that conditional from the policy is added to the query, right? So this means that indexes that are relevant to the overall query, including the policy, are able to be used. When you have a with check clause or part of the with check policy, then what that's going to do is check all new rows that are being stored in the table, okay? And it's going to check those regardless of whether it's an insert or an update. Okay, so if you do an insert, the insert is going to have a with check, and we're going to run that expression against the row data from the insert. If you have an update statement, we'll use the using clause to figure out what rows in the table you're allowed to run the update on, and we will use the with check clause to check the results of your update statement to see whether or not you were allowed to have that new row exist in the table. If you don't define a with check clause for your row level security policy, it will default to the using clause, as that tends to be what people want. Policies can also use functions, of course, as with functions in PL or in where clauses in general, that may prevent some optimizations from happening. If it's an SQL level function, right, that can be inlined, it could still potentially be inlined. But if it's like a PGSQL, we're not going to be able to optimize that. Yeah, question?
What happens if you're trying to update a row and you can select it? So let's say I'm updating and I'm allowed to see only New York row. So I say, hey, update the state equals California, where user is XYZ and he's in New York. So the select succeeds, but the update fails. It drops out of my.
So if you have yeah, we'll cover that a little bit later, but the short answer is that if you try to have, if the new row is going to violate the with check policy, we're going to throw an error back. We're not going to ever throw data away. Okay? So you're either going to get an error back, or you're going to get, your action is going to happen. Now, I will clarify that slightly. If you attempt to do an update on a row that is not visible to you through the using clause, then the update statement may run, and it'll just say, I didn't have anything to update. Okay? So in that sense, you could kind of consider that, losing data, but not really, because you could already do that in Postgres. So, but if you are allowed to see the row in the using clause, but it violates the resultant row, violates the with check clause, you'll get an error back. When it comes to policies and permissions, the way these things work is essentially the same as views, okay? So if you're familiar with how views works, this is not going to be too surprising to you. If you're not familiar with how views work, you might be surprised. Table references are handled similar to views in that tables accessed with the privileges of the owner of the table, right? So in the event that you have a view, for example, the way that it works is that the table accesses are done with the privileges of the view owner, right? With row level security, because policies are defined on tables, it's the same, but with the row level security policy table is the table access for the underlying table. Okay? And if that's an issue, you may want to use functions like security definer functions to address that, right? Functions in the policy definition, again, similar to views, are run with the privileges of the querier, right? So if you do select star from my view, any function defined in that view is going to run with your privileges. That's how Postgres works today. This isn't new, right? However, and the same is true with row level security. A function defined inside of the row level security policy when you query the table is going to be executed with the privileges of you, not the privileges of the table owner, right? Again, this is how it works for views, but it does mean that you always should be careful when accessing the objects that are owned by someone that you don't trust. Like that's just general good policy because of this particular risk. Naturally, if you don't want the functions to run as the privileges of the querier, you could make them security definer, and then they would run with the privileges of the function owner. Another big component to row level security that's important to understand is what's known as leak-proof functions. Okay? Functions in Postgres can either be leak-proof or not. Operators use functions underneath, and therefore, if the operator is using a leak-proof function, then the operator is essentially leak-proof. If, however, the function that the operator uses is not leak-proof, then the operator itself is not leak-proof, right? So why does this all matter? Well, leak-proof functions must not have any error conditions that expose data, okay? And what this means is that I can use this function against a column of a table, and nothing in that table will cause that function to spit out information about what is contained in that table. All right? Because we don't want this error case to be potentially used to expose data. Operators generally are. Things like equality, greater than and less than, right? Those generally do not have any kind of error conditions where they'll actually expose data, which is really, really handy because those are the things that you want to have be pushed down below your row level security policies to be able to leverage indexes. And that's the really big thing about leak-proof functions is that if a function is marked leak-proof, it can be pushed down below the policy. Okay? So if I have some query, select star from my table where x equals 5, that x equals 5 is going to resolve to a integer equality function that is marked as leak-proof in Postgres, and that x equals 5 is going to be able to be pushed down before any policies that are defined on that table, and therefore could leverage an index on that column x. We like that. That's great. Caveat to that, though, is that there are functions and operators out there that are not leak-proof, right? And not leak-proof functions can't be pushed down. And what does that mean? That means that we have to run all of the expression from the policy first, right? And it's got to be run, ahead of anything, ahead of exposing any of that data to those functions that are not leak-proof, right? A great example of this is casts. Casts are often not leak-proof, right? And that's because, you do something like this, and it's going to give you, hey, invalid input syntax for this data type, and then it's going to give you the data out of it. That's not a leak-proof function. And therefore, we can't push it down below the RLS policy. So if you are, writing a where clause and you end up having to do a cast in it before the equality, that may result in a case where we aren't able to actually push that down below the row-level security policy. And that might suck, right? That might not be ideal. So when you're doing your analysis of performance around tables with row-level security policies, this is something to consider. Also, you can check the pro leak-proof column in PGProc in the catalog to see if a given function is leak-proof or not. I will say that Postgres hackers have gone and looked at all of the functions that are marked as leak-proof, and we believe that they are. But that doesn't mean that every function that is not leak-proof actually leaks information. So if you find a particular operator or something that you feel like, hey, this should be marked leak-proof, I encourage you to put some effort into it, see if you can really prove it to yourself, and if you're able to, bring it to the list, right? I think that we are open to making more things leak-proof, either by just virtue of the fact that they are naturally leak-proof, or possibly by making modifications, if it's something that we think would be reasonable, to allow those to be leak-proof, because, again, that can really help with query optimization. When it comes to permissive versus restrictive policies, so these are two different types of policies that exist inside of Postgres. Permissive is what the default is if you don't specify something, and what that means is that we combine all of the permissive policies using OR conditions. So if there's 5 policies on a table, 3 of which apply to your role and whatever command is you're running, all of those will be combined with OR clauses, meaning that you can access whatever row you could access with any of those policies, right? That's permissive. We do also support restrictive. I think this was added in version 10, if I remember correctly. And restrictive policies, on the other hand, are always applied, and therefore they are also combined using AND. So 2 different ways to go about structuring your row-level security policies, and using restrictive ones may be a little bit simpler to design and to demonstrate how they work for auditors and other such wonderful people. We love auditors. If there's any auditors here, we like you. If there aren't any auditors here, we'll have another conversation. So when you want to go use row-level security, as I mentioned before, the first thing you need to do is enable row-level security. This is done on a per-table basis. And once you've enabled it, it requires all access to go through some policy, either a permissive one or a restrictive one. And there's a default deny policy if there is no policy defined for the table. So once you enable row-level security, if you try to query that table, even though you might have access to query that table, if there are no policies but row-level security is enabled, you won't see any rows. It'll appear to be empty to you, right? Any command you run, update, delete, will just return 0 rows, right? Because those commands all consider the table to be empty, and if you try to do an insert, of course, that's going to fail, and you'll get an error back from that insert, right? This does exclude the super user and the table owner by default, okay? So super users and table owners are always excluded from all policies, by default. We'll talk a little bit more of that in a minute. When you disable row-level security, it'll basically stop applying any policies. It'll also stop doing the default deny policy. Policies that exist are just not going to be used anymore, but the policies still exist on the table, right? We don't actually drop the policies from the table when you disable row-level security, so they'll still be there in the event that you want to, maybe re-enable row-level security at some point later. You can do something called force row-level security. So if you run alter table force row-level security, this will cause row-level security to not exclude the table owner. This is really useful for debugging purposes, okay? This does not prevent the owner from being able to do anything because the owner can always go back and turn it off, right? This is similar to the grant system. Like, the owner can revoke their own access to the table through the grant system, but they can also grant it back. So it doesn't really prevent them from being able to do anything. Now, this is something that's kind of nice because we have this for row-level security and we don't have this for views. But you can actually tell Postgres that you don't want to ever mistakenly have row-level security applied. There is a GUC called row security that you can set to either on or off. Now, naturally, on is the default, meaning normal mode policies are applied for any tables where it's enabled. If we set it to off, though, then this will cause row-level security to never be applied. Instead, an error will be thrown if row-level security would have been applied for whatever query you're running. This is useful to avoid mistakenly having RLS apply when it's not intended, and in particular was implemented in part for pgdump specifically. So pgdump we view as a export tool where you probably want to export the entire table and not just some portion of it. So the idea here is that pgdump will set row security to off by default, so that when you pgdump something out, you get the full contents of whatever you've asked pgdump to export. There is an option to pgdump, however, to tell it to enable row security if you want to dump out just those rows that are in fact visible to you. Was there a question? Yes?
Do you guys audit anytime a table owner turns RLS on, off, or changes policies or applies policies?
Is there a way to audit that? So there is an extension to Postgres called PG Audit that can provide a lot of auditing capabilities. It can be used to audit accesses to tables. I believe it can also be used to audit DDL on tables. And I think it can also be used actually to audit GUC changes, but that ends up getting very noisy. And so you may or may not want to do that. I don't think there's a way to enable in PG Audit today to audit just specific GUCs being changed, but I'd have to go check. If you're curious, David Steele, who is around here somewhere and hates that project, but he wrote it and is a rather world expert on it, considering he took it and rewrote it, and from a prior effort. But he is here at the conference. Tall, balding guy, white. I don't know if that excludes anybody. Sorry, David, not you. Not this David, a different David. Sorry, what's the question?
I mean, the idea is just because I'm your best friend and you're the table owner, you would change RLS, allow me to update, whatever I like in terms of compensation, turn it back off. Somebody needs to keep track of that, right?
Yes, but I don't know that this particular row security option is relevant in that regard, right? If I wanted to, as the table owner, I could create a policy just for you that allows you to access it.
And hence important to audit, right? Any changes that you make.
Sure. So yeah, I mean, I would strongly recommend always enabling logging of all DDL, right, just from the get-go. And then, further you can use PG Audit to allow you to pick and choose what objects you want audited. That's a capability that exists in PG Audit. So I encourage you to look at PG Audit. Maybe that answers the questions for you.
Make sure you have a limited space for your logs.
All right, so how do we create a policy? So create policy is done through the create policy command, perhaps not surprising. You can specify that the policy is to be for specific commands. We'll talk about the different commands that you can specify. You can also define whether you want them to be for a particular role or whether you want them to be for all roles. As I mentioned before, there is a default deny kind of policy if none exist. And then you specify your using and with check clauses. And if you don't specify a using clause, or sorry, a with check clause, then it'll default to using the using clause. So this is the full syntax for the create policy command. And I'm just going to kind of walk through each of these. So here's an example of creating a table and then creating a policy on that table. So you don't have to specify very much. There's a lot of defaults that exist. So in this particular case, you can see here that we're creating just a simple policy. The only thing that we're passing in is the using clause. But what does that mean underneath, right? What that means underneath is that the with check clause and the using clause are going to be the same, right? So that's kind of the first piece. So we took this very simple thing, and now we're just kind of expanding on it with what the defaults are. Next, as permissive. Permissive is the default policy type in Postgres. So when you create a policy, as permissive will be the default. For all, this is saying this is going to be for all commands, right? So, whether it's a select, an insert, update, delete, this policy is going to apply to all of them. To public, this is saying public is the role that everyone has access to. And so to public is to say this policy is to apply to everyone. If you wanted to create a policy specifically for select queries, you would do that saying create policy for select. When you create a policy for the select command, you can only specify a using clause, right? Again, the using clause says what rows are visible to this command. There's no sense in having a with check clause for a select command because a select does not insert or update rows in the table, right? So the with check doesn't make any sense because it wouldn't apply to anything. So if you try to specify a select policy and a with check expression, it'll throw an error because it doesn't make any sense. So for insert, on the flip side, insert only allows a with check clause because there's no sense in a using clause. Because when you're doing an insert, you're not actually accessing any of the rows in the actual table, so a using clause doesn't make any sense here. Now, if you do an insert into table select star from table, right, the select star from table will utilize the policy for select, while the insert will use the policy for insert. So you'll actually have two different policies that get involved in that case. Similarly, for update, so obviously when you do a for update, that only applies to update queries, but because an update accesses rows that exist in the table and causes modification to those rows, and the resulting rows go back into the table, this actually allows you to specify both a using clause and a with check clause. If you don't specify the with check clause, of course, the using clause is the default, just as if you had said for all as the default that I showed earlier. So here you can actually even create a policy that will end up allowing you to create rows that get hidden from you, right? Because you can say using, my user equal current user, but with check true, right? And this will say, okay, well, if I do, if I find a row where my user equals current user, and then I go and make a change to that column to set it to somebody else, well, and then I run the with check clause on it, and that's it. Well, that's fine, right? Then it'll actually change it to be hidden for subsequent update commands at least. Policies for delete. This is similar to select, right? Delete doesn't ever add rows to a table. So it only allows you to specify a using clause for delete. When it comes to altering policies, this allows you to change policy definitions. You can also change the set of roles that the policy applies to. Just a point here about roles. As you note down here in the syntax, you have to role name and then a comma. So you can actually have multiple roles be specified as part of the policy definition or as part of the alter policy. Similar to the grant system, though, I would generally encourage you to create a role and grant the other people into that role rather than having a long list of roles here. If you have a long list of roles on the policy, or if you have a long list of roles in your ACL, it's not terribly performant, right, the way we access those things. So I would generally suggest it's better off to actually have a single role here that you then grant other roles into, and it's just better policy, in my opinion, for how you manage access as well. You cannot change the command for a given policy. And this is because of the whole, like, some commands you can have using clauses for, some commands you can have with check clauses for. If you wanted to change the command of an insert policy to suddenly be a select policy, like there wasn't a using policy or using expression for the insert, right? So what would we use on the other side? It would just be weird. So we don't allow that. Instead, you can just drop and recreate the policy. And as with all other, just about all other Postgres DDL, you can do those inside of a transaction, right? When you are making changes to policies on a table, it is going to take out a strong lock, but updating policies is very fast, so usually not an issue. You just want to make sure that any ongoing concurrent transactions are relatively fast so that it can acquire the lock pretty quickly. You can also rename policies if you want to. I know that's exciting. Here are some examples of altering policies. So you can change the using clause, or you can change the with check clause. Again, you can change the set of roles that a particular policy applies to. And you can do all of these things at once if you want to inside of one alter policy command too. Yes, sir.
What kind of locks do these take?
So all policy modifications are going to take out a pretty heavyweight lock. I'm like 99% sure it's an exclusive lock, an exclusive access lock. So, and that's just a matter of like, we want to make sure that we get a lock on that so that any later queries are going to utilize whatever the current policy definition is.
It makes a lot of sense. It's just that in really large systems, you have to be a little bit careful of anything that might throw it in access.
Yeah, of course. So that's what I was saying, right? If you're going to make any of these kinds of changes, as with a lot of other DDL, you want to make sure that any ongoing queries are ones, or ongoing transactions are ones that are going to go fast. Yes, Mark?
You're doing on conflict do update that you're using an insert policy. Does it apply to the insert using clause as the with check clause, or does it just not have a with check clause?
I believe the former. I'm fairly confident about that. Peter Gagan is here. He and I had a fair bit of discussion about the whole, on conflict, do whatever. So he might be able to give you a confirmation of that, because he and I did talk through that, but I'm fairly confident it's the former.
Would there be a call for a new feature where you could add the check clause, or does it seem overkill?
At the end of the day, as far as I'm aware, it hasn't been asked for yet. And so without someone asking for it, it's kind of like, but, if you can think of a use case, or you see someone who has a use case where it would be relevant and you're interested in it, definitely bring it up, and maybe it's something we would add. Dropping policy. Oh, don't talk about merge. Dropping policy. Sorry, that was a side joke. Dropping policies. So naturally, you can drop policies, of course. There is also an if exists that you can use with drop policy. Just remember that when you are dropping policies, that at the end of the day, if you drop all of the policies, then that default policy of default deny will be applied for subsequent queries. So let's talk a little bit about the policy system versus the grant system, right? So when you're talking about the grant system, that is basically all either table level or column level, right? Depending on what type of action you're talking about. And the grant system is, it's an all or nothing kind of thing, right? Either you're going to get an immediate error, right, saying you don't have access to do whatever it is that you're doing, or the query is going to go through and you're going to get whatever you ask for, right? Traditionally, views have been used with, to limit access to rows. I will point out, however, that with views, if you're using views to simulate row-level security, you need to make sure that you're marking those views as security barrier views. This is really, really important because if you don't mark the view as a security barrier view, then that whole leak-proof function and push-down of functions and stuff is ignored. So if you have a view and you're using it for permissions, you need to make sure to mark it as security barrier. If you don't, somebody might go create a function and cost that function really, really low, right? Really, really small. And what will then happen is Postgres will be like, well, this function is really cheap. I want to go run that first. And it'll actually push that function down below the quals, right? Below the where condition in the view. And the owner of that function will then be able to see all of the rows of the table. So if you're using views to simulate row-level security, you need to make sure that you are marking them as security barrier. Now, naturally, that also is going to mean that security barrier views, similar to row-level security, leak-proof functions are still allowed to be pushed down below the quals inside of a security barrier view, whereas functions that are not marked as leak-proof are not allowed to be. Random side note, may be relevant, only super users are able to mark functions as leak-proof, right? As you might imagine, because if you're able to mark a function as leak-proof, you could then use it to bypass either security barrier views or row-level security, and you wouldn't really want that. Any questions about any of that? So when it comes to the policy system, unlike the grant system, this allows you to have table-level row selection through this conditional being added to queries and errors for rows that get added which violate the policy. So unlike the grant system, which tends to be everything or error, the policy system allows you to get a subset of the table in terms of what you're allowed to access, whereas if you tried to access all of the columns, say, of a table that you don't have access to all the columns of, you would get back an error.
So this sort of, right, the last bullet point is always in other DBMSs that provide similar constructs is a sort of point of contention where let's say you have sales reps and each of us have responsibilities for our regions, and let's say I have New Jersey and you're California. I run a query, say select Comstar of customers where state is California, and if I get an error, then I immediately know there is a row for somebody in California that, so I can deduct it, right? I can deduce it that there are rows for somebody in Belgrade, for example, right?
Sure.
Which, if I get an answer back saying 0, then I can guess whether the answer is really 0 or I'm not allowed to see it, hence it's 0.
I mean, that is a fair point. I will, and so I think, I feel like you're arguing for the way that we handle it as being better, which I would tend to agree with.
No, actually, if I get back 0, then I don't know whether it's really a 0 or...
But you wouldn't, I mean, if you don't have access to those rows, then should you be able to deduce whether or not there are rows there or not?
I should not, right?
Right, and so Postgres, I mean, theoretically, Postgres, yeah, you'll get 0 back with Postgres.
Yes. Yeah, if I get 0 back, then it's fine. But if I get
That is how Postgres works, just to be clear. Yeah, row-level security, if it doesn't pass the using clause, you just won't see that row. It'll come back with, it won't error. The errors are when you try to do an insert. Like if you do an insert and that row that you're trying to insert violates the policy, then you'll get an error back.
the select will not give me an error.
No, a select query, I cannot think of any way that a select query as modified by a policy would end up giving you an error, right? It's not going to give you an error. I mean, if the policy was defined using a cast and the data had a cast, was invalid or something, yeah, okay, yeah, maybe, right? But yeah, no, as long as the policy is well defined, you're not going to get any error back from a select, right? It'll just come back with 0. Now, I'm gonna caveat that slightly, right? And the reason I'm going to caveat that is that the argument you're making is that a user wouldn't be able to tell whether there were any rows with that value or not. Reality being, if they have unfettered SQL access, I mean, you could do timing-based attacks and other things that could potentially allow you to deduce that information, right? But it wouldn't be explicit. Postgres, in implementing row-level security, we acknowledge that there are what we consider covert channels for finding out information there, right? Another way that you could find that information from tables that maybe you don't have direct, or rows that you don't have direct access to, is that foreign key relationships, right? If I'm allowed to insert into table A, and table A has a foreign key to table B, and B has a row-level security policy on it, it doesn't matter, right? Like, the fact that I can insert a certain value into A and that foreign key doesn't blow up means that that value obviously exists in the other table, even though I can't see it. But, so that is another kind of case where we consider that a covert channel, and it's not something that we intend to address with RLS, right? We aren't going to allow things to just get inserted that would then be hanging, right? The foreign key has to be respected.
No, that makes sense. I mean, this thing becomes far more prevalent when you have column level security, right? In column level security, if I'm allowed to see a customer's record but not his social security number, then I can concoct a lot of SQL statements that we need.
So, I mean, we do have column level privileges in Postgres. So, but you're right. I get that point that the combination of the grant system, particularly with column level privileges and row level security, really gives you a lot of flexibility in terms of defining who has access to what. There's been some discussion about possibly extending this to allow you to do more with row level security than what we provide today, or do more, more generally with policies than we support today. There's certainly different things you can imagine about how we might do that. Masking has something that has come up a few times on the lists as something that might be interesting for us to support, and I could see us doing that maybe at some point in the future. For those who aren't familiar with the concept of masking, it's basically, if you have a credit card number, you're going to only be able to see the last 4 digits or something, right? That's an example of masking. Right now, you can't really do that with just regular tables and column level privileges and row level security. You can do it with views, right? You could define a view. Be sure to mark that view as security barrier if that's the direction you want to go in, though. Sure. So inside of PSQL, if you were to do a \d on a table, this is what a policy defined on a table would look like. This is that same policy that we were defining earlier, where column myUser must be equal to current user, which is a built-in function in Postgres that just returns the current role name. Here, as a super user, right, you can tell that from the hash. If I do table T1, which is actually SQL standard command for people who aren't familiar with it, and it just means select star from table. Here I can see all 3 rows. However, if I change my role to be R1 and then I query the same table, I'm going to only be able to see that R1 data column, or that R1 row rather, right? That's the only data I'm allowed to see. Since I didn't specify any with check clause, the using clause is used. So if I then try to do an insert into the table, trying to put data in on behalf of R2, for example, I'm going to say, oh, well, that new row violates the with check clause, and therefore it's going to fail, right? And then it'll report what the failing row's contents are, but you also specified those when you passed in the insert, so I'm not leaking any information here. So as I mentioned before, you can have a with check clause that allows you to actually, if you just mark it as true or make it more permissive than the using clause, then you can even have a case where you could actually insert rows that you aren't able to see, as shown here. Not something I really generally recommend, but I have had people ask me about it before, because some people like to build systems where they can give rows away, which I think is an interesting system. You can talk to Joshua about it if you're curious. All right. Maybe there's a few. You can also have external policy systems be involved. So for example, because these are expressions, we can basically have any function involved. So you could have potentially like a call out to SE Linux as an example, where what will happen is that this function check SE Linux will be run for every row being returned, right, from the table to see whether or not you are allowed to see that particular row. I'm going to run through a Unix password file example here really quickly, and then I'll take some, I should have a few minutes left to be able to take some questions. So standard Unix password file, right? Username, password, UID, GID, right? And then I create a few roles, right? Admin, Bob, Alice. I'm going to populate the table with some data. Here I have an admin, a Bob, and an Alice row in this particular table, with information like phone numbers, root directories, and shell. Then you have to make sure that you enable row-level security on the table. Once I've done that, I can go create some policies. So I'm going to say the admin all policy allows the admin to do anything with the table, basically. See all the rows and insert any new rows they wish to. I'm then going to create a policy just for, so note that that first policy was granted or created to admin. So only admin roles are going to be able to actually see that, right? Or be able to access this table through that policy. I'm then going to create a policy for the select command that applies to all users, right? And you see that because I don't specify a to clause here, right? And so the default public is used. And that's going to say, okay, anyone is able to select any row, okay? And then I'm going to create a modification policy where I'm going to say, okay, users are allowed to modify their own row, but they can't change the current user, right? So uname here has to be their, current user is going to be a function that runs to get the current role name, and that has to continue to match uname. So here I have the using clause and the with check clause, they both have that same conditional in it. So note that this is a for update command, right? So this is applying just for updates. And then I'm also going to say, I'm going to have a check in here for the shell command, right? So what this says is that users are allowed to change their shell to any of these values. Admins could change their shell to whatever the admin feels like, right? So users are more limited in what they can do than admins are. Yes, you could do the same thing in a trigger or something, but it's a little bit cleaner, I find, to do it through a policy like this when you're talking about what users are allowed to do what, right? You could have similar conditionals to that inside of a trigger or something, but I find it cleaner to do that inside of the policy.
Are you allowed to reference other tables in the policies like
Yep.
using and
Yes, so just about anything that can go into a where clause can go into a policy, right? Because that's what happened. We take the policy and we shove it into the where clause, right, during the rewrite stage. That does include references to other tables, yes. You can't put like aggregates in there, right? Things like that you can't put into a where clause, you can't put into a policy. But things like referencing other tables, you definitely can. So further, we're going to then utilize the grant system as well to control what columns user is able to mess with, right? So here we're going to say I'm going to grant select, insert, update, and delete on, for the entire thing, for all columns to the admin role. So the admin role, again, can do anything. But users are only going to be able to select out certain columns, okay? So this is a grant select on password to public of only the public information. So the password column, for example, is not here. So users cannot query out the password column of other users. In fact, users can't even query out the password column of their own, right, user. We then are going to grant update access. And we're going to say, okay, users are able to update some of these columns, like the password, real name, home phone, and shell. But with the combination of row-level security, an update command that's run is only going to see the one row in the table that matches the username of the person running the update statement. So let's look at some examples here, right? So here as an admin, I can see everything, right, as expected. As the role Alice, however, if I try to select the entire table, it's going to throw an error because I don't have access as Alice to all of the columns. I only have access to a subset. So here I can select out the subset of columns I have access to. Further then, if I try to update the table to change the username to be some other user, that's going to give me an error, right? Because the one row that I can see is the Alice row. I'm going to try to do an update. The update row is going to result in a uname of Joe, and then I'm going to get, well, actually, sorry. In this case, I didn't allow column level access to uname, but this could also have been a row level security failure. But in this case, this is actually a column level access failure. Sorry for that. So trying to set username, Alice doesn't have access to modify the username. She doesn't, Alice does not have update rights on that column. If I set update password and just set real name to Alice, so that updates one row because the update command only sees the one row that is Alice's row. There's 3 rows in the table. Alice could even see that. But when Alice runs an update statement, that update statement is only going to see the one row that is Alice's. So you can see that also here if I ran an update with a where clause that said where uname equals admin, because I know that an admin row exists, well, guess what? That's going to end up not finding any rows because there aren't any rows that the update statement can see that are that have that uname. If I try to change the shell to one that wasn't defined in the list that I created earlier, then I'm going to get a with check option failure for that table because that new row violates the policy. If I try to do a delete, that's the grant system again. Alice does not have delete access at all on the table. If I try to do insert, again, grant system. Alice does not have insert rights on the table. But Alice does have access to change her own password. I will clarify this, however, don't ever store passwords in clear text. Don't do that. This is just for an example of row level security. All right, I'm being told I have to stop. I will be around. You're welcome to come find me later on, and thank you all for coming to my talk.